3, 2, 1.
Okay, the last video that I made about rockets on my YouTube channel is now the most viewed video on my YouTube channel. So, you guys clearly want to see more. And here we are. Alright, I want this rocket to be some sort of a test bench so that I can test different systems in the AV bay, like different flight computers, altimeters, pyro channels, all kinds of different things. And I want to use it as a test or a practice test for my L1 certification, which, if you don't know what a high-powered certification is, there's basically 3 levels of certification, and each one allows you to buy bigger rocket motors.
First, I started designing everything in FreeCAD and in OpenRocket. Then, I cut the fins and sanded them so that they were straight and chamfered the edges. Then I cut the body tube and the motor tube. After I finished removing all the supports from my 3D prints, I made sure the fins fit inside of them. Then cut the fin slots in the airframe. I made sure that the fins fit properly in the 3D prints and airframe, then hot glued them all together. I spray painted all of the pieces, including the inner assembly, the coupler, the nose cone, and the body tubes. I tied on the shock cording to the inner assembly and used a bit of hot glue to make sure the knot would not come undone. Then I screwed the launch lugs onto the airframe and the AV bay. I glued the inner assembly into the airframe. Then cut a eye bolt in half to use as the connector for the AV bay to the shock cording. Glued that in and glued the knot so that it would not come undone. Then I put a little tape around the connector that connected to the AV bay and the main airframe so that it would not be as loose.
At this point, the rocket was ready to fly, except for the components in the AV bay and a parachute. So I asked one of my fellow rocketeers to make me a parachute out of red nylon with a canopy of 24 inches and shroud lines of 48 inches. As for the AV bay, I wanted to test out a new flight computer and have a tracker so that I could actually retrieve the rocket if I couldn't see it with my eyes. I've never made a flight computer before, and I didn't want to risk designing one and then messing it up since we were so close to the launch date. So I ordered a commercially available kit called the Egg Timer Ion, and then I soldered it all together.
So, Aidan soldering this tiny piece, like how long it take? I don't know.
Like 2 hours.
2 hours?
3 hours.
Wow. Tiny but beautiful.
Yeah.
Look at
And that's
this
only the top.
detail.
The bottom is even more complicated.
Yeah, look at this detail. I cannot show you the bottom, but that is
I'm not unscrewing it. Okay.
beautifully done. Awesome.
I would definitely recommend the Ion. Or they make more powerful ones that have pyro channels if you
Here, if
want
I
to.
get one, I'll have you solder it for me.
Okay. Is there a way to test continuity?
Yes.
If we could do that, that'd be great.
We're going to go back to individual launches. That is armed, and we're sending up AI bot. In 5, 4, 3, 2, 1.
Wow. That was smooth. It was smooth.
There we go.
And the shoes
Beautiful.
up. Good job.
Decent.
I think the passengers are going to applaud that takeoff. They hardly felt it.
After I retrieved my rocket and I viewed the flight data on the flight computer, it only reached 381 feet, which is very surprising because in the simulations, the rocket was actually 20 grams heavier than it was in real life, and I simulated higher winds than we had on the launch day. So it's almost confusing, but one of my fellow Rocketeers, the same person that made the red parachute for me, thinks that there was drag on the actual, on the launch lugs. And so if you look directly down the barrel, you can see, let me turn this one, you can see that it's not directly in the center of the fins, which is a problem, but I figured it would be fine since the second launch lug can spin and I can align it on the launch rail, which I figured would be fine. But she thought that that created too much drag, which I kind of believe her, because if you have, this is the rocket body, and imagine this is the cross section that goes like this is the cross section that goes like that, and then this is the rail. Normally the pins are supposed to be like this. I think mine were like this. Obviously exaggerated, but that could have created too much drag if you review the footage. It took a while to get off the pad, and since it did take a while to get off the pad, the motor had burned out in the amount of time that it took to get off the pad, so it couldn't accelerate as fast, and therefore it didn't go nearly as high. In the future, I want to launch this rocket on a G motor, which a 29mm G motor would be twice as powerful, or nearly twice as powerful, seeing as how classes double. That's how classes work. Which, also, I teach you about classes in my podcast, which I'll leave a link in the description if you want to go watch it. Until next time, never forget to ignite the skies.
Armed. We're going to send up the Phoenix in 5, 4, 3, 2, 1. There she goes. With a mighty roar.
Still going up.